Hello, my name is Dan Popovich. I'm a mechatronics application engineer with Festo, and today I will show you in this video how to connect an SMS from Festo Simplified Motion Series in this image using IO-Link Master from Festo to a Allen-Bradley Compact Logics PLC. We begin by launching the Festo Automation Suite, and the first step will be beginning a device scan. The software searches the Ethernet connection and detects all the connected hardware. In this case, we have the first module, our CPX-AP-I EP. We add it to the project. Next is the CPX-AP-I for IOL. We add it to the project. Then we navigate to the project page, and we see both devices added to the project. Next would be to add the SMS, and we do that manually by entering the part number, material number. That is found here on the back of the motor. We enter it, select it, and add to the project. We move it closer, we make the connection, IO-Link connection, and also we make the Ethernet connection. We open a new tab. We enter the IP address of the IO-Link master. In our case is 192.168.1.10. And here we see the same setup we saw on the FAS, Festo Automation Suite homepage. Next, we click on the IO-Link master and we set up a few parameters. We select low supply monitor active. We make sure everything is set up as fast as possible. Then we leave the diagnosis enabled for the ports, all 4 ports, even though we use only the first port. Then on port 0, we select IO auto start. Port 0 validation backup, we select type compatible backup restore. And we leave everything untouched. We go all the way to the bottom where we select variant 2. This is the configuration we need to do on IO-Link master. On the CPX-AP-I EP, we have this low supply monitor active, check, and we have the IP address. We change the IP address using the FAS, Festo Automation Suite. After we finish configuring the IO-Link master, we select Ethernet IP from the top menu, and we generate a program, L5X Rockwell project. We select that. We check enable and write access, uncheck SNMP. We can change the name here. We don't have to. We select using exact IO length and as the DIMM type. Select complete system and global diagnosis and module diagnosis. We hit submit, and then we click download. After the download is complete, we go to the downloads folder, and that's where we find the file we have just compiled from the FAS tool using the web browser. It's called CPX-AP-EP.L5X. We double click on it, and that will begin a conversion or an import process from the export file to the RSLogix 5000 Studio project file. It takes a few minutes. Here we are. We select the revision number, 36 in my case. Here we can rename the file if you want. I'm going to leave it alone and hit import button. I already done this before, so it's going to replace my older file. And this process will take probably another minute. The import is done. We navigate to the main program. and we find the rungs that were included in that file export. Our project doesn't have an AOI enabled yet or added to the project, so we're going to the Assets, Add-on Instructions. We right-click and select Import Add-on Instruction. And we scroll down to where we have previously downloaded our Festo Advanced or the other add-on instructions from Festo website. I select Festo Advanced. Hit OK. So the importing is done. I'm going to create a new rung here and drag that AOI that I have downloaded from Festo website. Next, I'm going to show you how to go to Festo website and download the AOIs. I am back on the Festo website. I'm selecting the Tooth and Belt Access Unit, ELGS. You just type in ELGS and takes you to that web page. At this point, the SMS can be installed on any type of actuators. So I select one of them. Then I go to Downloads, Expert Knowledge. Then I scroll down and look for SMS Control by Allen-Bradley CPX-AP-I IO-Link. I select that and then begin the download. We are back in the Downloads folder. We see the folder we've just downloaded, and I've extracted the files from that folder into this new folder. And under that larger folder, we find several different folders, which are sample codes, AOIs, different AOIs, and application node. The application node is a PDF file that explains to you step by step how to do this implementation, how to map the AOI and how to download, how to format messages and everything in detail. So this is the go-to manual in case you need to make some corrections or adjustments. We're backing out of this. In our case, we downloaded the SMS Festo Advanced. That's the AOI that we'll be using for our project. Now we're back in our RSLogix 5000 Studio. We have previously added the AOI, and now we have to configure it. But before we do that, let's make sure that the IP address of our SMS unit is the address we want to use in our project. So in our case, we use address 10. This is the data communication format. So if by default your actuator was a different address, you can go in here and change it. So for now, we leave it at 10 because that's what we have on our installation. Now let's begin by filling out the information on this AOI unit. First is the tag name. We'll call it SMS Advanced. Make a new tag, SMS Advanced. Then we create another tag, link event code. Call it event code. Create new tag, integer 16. Next, we create a message source element. We call it message source array. And message write array or destination array. We create new tags, SYNT48. New tag, SYNT48. Now we create two control tags for the read and write messages. We'll call it MSG read and MSG write. Create new tags. Now we go and configure the tags, the messages, sorry. Communication, we select our CPX-AP-I, hit OK, and also we add a (3, 1). 3 is for IO-Link, and 1 is the port number on the IO-Link master. Hit apply. Then we go in and configure the message. For the service code, for the read message, we have for B, class 10B. The source message, we select message source array, source 0, destination, message destination array, 0. Hit apply. We have no errors, so we're good. Next, we configure message write instruction. We select the module. We add (3, 1) for IO-Link and port number. Go back to configuration. Service code 50, this is the write, and 10B for class. Same thing for source. We select source array for message, byte 0, and destination array byte 0. And we hit apply. And we finish that part. Next is to map the inputs and outputs. And as you can see here, in the previous rounds, we copied the raw data into our CPX-AP input. So we kind of pre-mapped our data as it comes raw from the actuator, from the CPX-AP-I. In this case, I'll show you where the data is. Here's the raw data, CPX-AP-I for inputs and outputs, status and control. And we're moving it into this data. And we're using port 0 in our case. Here goes port 1, 2, and 3 if we have multiple SMSs. So we'll be using port 0 for inputs and port 0 for outputs. So let's go back to the UI and map this. So as we saw in the manual, we have the S source, we'll have this word for the source. Destination, we'll make a new tag input, will be integer type, and destination bit will be 0, length 8, source bit 8. And we transfer that to the UI. So we swap the bytes. In our case, with the variant 2 we selected, we swap the bytes. So we take the raw data, we move it to the inputs tag, and then we swap that byte that we map to the inputs of the SMS AOI. We do the same thing for the outputs. We copy this instruction, we paste it here. But in this case, we're going to create a new tag. We call it output. Integer. So the SMS will send a message to the output word, and that will be mapped into the output word that we've created previously through those previous rounds. So we navigate to CPX output, module 2, port 0. And in this case, we're not swapping here. We start with the source bit 0, and we place the output word from the SMS into this address, port 0, will be destination bit 8 in this case, and length 8. So this is how we transfer the data in and out of the SMS. Next, we have 2 more tags to create. One is connection faulted. In order to do that, in order to create the connection faulty tag, we have to do the following. We need to add a new rung, and we need to read the status of the device, the Ethernet module that we assign to the SMS. So we'll use an instruction called get system value. We'll have class name module, because it's an IO module. Instance. For instance, we drag the IO name here. For attribute name, we select fault code, and we create a new tag where we place that fault code. In our case, we'll call it CPX error code. We'll create a new tag, we'll leave it as dint. And then we check if that tag is equal or not with 0. Not equal. It's not equal to 0. And if it's not equal to 0, we'll create a tag, and it will turn the tag on or off. And we call that IOL master error or fault. It's a Boolean format, Boolean tag, and we drag that straight into connection faulted. And we have one thing left to map, is device available. For that, we navigate to our inputs on the status, module 2, and we select for PQI. So this is it. We finished the mapping. But to have more aid on how to run the AOI, I'm going to add a few more tags here, a few more instructions in order to do this. So I'm going to add a few instructions, and then I'm going to add, I'm going to map them to my SMS Advanced. First to enable, next is to do a read all, then a write all, move out, move in, move intermediate, reset error, and reference. So in execute reference, that's for homing. Now I'm going to download the program to my processor. Go to communications, we select who active. I'm browsing my network. I see my processor, Compact Logics, address 100. I set the project path and then hit download. The import was created for an 1769 L30ER, and in my case I have a 1769 L36 ERM. I change the controller type, yes. And select yes to download. Okay, my IO LED, the green light, it's solid green. That means my communication is working properly. I have no errors. So I'm back with my AOI. Got all my tags lined up here, mapped, so it's easy for me to toggle them in this format. I have my enable on, off, back to on. Here's copying the input board into input tag after byte swap and placed it in SMS. Same thing, my output from the SMS AOI, I moved it into my output tag and I do a byte swap there too. So now I'm reading everything. I'm going to do a read all, enable read all, write all. Once that's enabled, I'm reading all the information from the SMS. I don't need to have write all enabled all the time. I turn it off. And I begin by referencing the SMS. And I do that by toggling this bit. SMS advance in execute reference, which is the same thing, a tag that is here. In execute reference. As you can see, by referencing works. And as you can see, the referencing worked. I'll show it to you one more time. I'm going to re-reference it again in the code, in the program. See, it's moving in. Checks both end travels and then moves out again. Okay, so now we have the current position. It's 20,332. We're going to set the speeds. I would like to use for speed out, in, and for the force I'm selecting 8. Default is 1, but I want to have more force to defeat the friction in the slide. And then I'm going to set the positions. For position out, we are at 20,333, which is 203 millimeters. And our current position is the same, 203 millimeters. For position intermediate, should be less than that, should be, let's say, half of that. I'm going to go with 10,000, which is 100 millimeters. And for the start press, it can be the same as the position out, but I'll select something less, like at least 20,000 instead of 23,000, which is 200 millimeters instead of 203 millimeters. And now we can begin cycling the actuator in and out. Let's begin with we are already, the status state says it's out. You see it here. So I'm going to begin with a move in. So I'm toggling the in, move in bit, which is the same as in here, in, move in, but I put it on the ROM so it's easier for me to toggle. It moved in, toggle it back off, and then move out. As you can see, the position and the speeds are updated here. I'm going to do the same again, but this time I will show you the camera. Move in, move out, and move intermediate, halfway, or whichever position I choose to select for intermediate. So here we are at the end of the video. We're successfully integrating the Festo SMS using IO-Link Master from Festo with the Rockwell Compact Logix PLC using RS Logix 5000 or Studio 5000 software. Thank you for watching.